Hi everyone, my name is Markku from the University of Oulu, Finland, and I'm presenting our work claiming that unwinding rotations improves user comfort with immersive telepresence robots. So before we get to the main point, let's discuss immersive telepresence, the use case we propose. So essentially we have a remote user who's wearing a virtual reality head-mounted display, an HMD. On the left, the figure is also from our user study. Then somewhere else is a mobile robot, which is equipped with a 360-degree camera streaming video into the HMD, such that the user can just look around in the remote environment as they normally would. They can also move the robot around, tell it to move somewhere with some unspecified means. So why should we use an HMD over the current commercial telepresence robots, such as the beam on the left? They are much nicer looking than our prototype on the right. So the main reason is immersiveness. So an HMD is more immersive, so you are kind of really in there because all you see is the environment. And that has been shown to have a strong connection to presence with the work of Mel Slater. Then why do we care about presence? There's an interesting study in HRI a few years back showing that in a group work, if there were 3 local people and 1 person through a telepresence robot, the person through the telepresence robot spoke less and found the tasks more difficult. And we believe that might be due to the lack of presence. They really didn't feel as if they really were there with the other people. So why isn't everybody then using HMD? So a few challenges, a couple of technical challenges with bandwidth and stitching images from multiple videos together. They are under active research. They are not really our concern. There are already research level solutions to this. VR sickness, however, is what we care about. So similarly as you might get motion sick in a car, you might get sick in VR because your eyes see something, but your vestibular organs sense something else. So you see rotation on the screen, but you don't sense it. And that can cause nausea, headache, even vomiting. So to remedy that, we propose unwinding the rotations of the telepresence robot such that the user never actually experiences the rotational motions, which are shown to be stronger than translational motions in causing VR sickness. How do we do that? So just if we look at the figure, in figures A and D, the robot is approaching a cross-section. Figure A is the user's point of view. And then the robot makes a turn. And if the rotations are unwound, so the robot rotates right. However, the user's viewpoint at the same time rotates left. So the user never sees the robot physically rotate, but keeps staring at the wall, and then the robot starts moving from the user's point of view to the right. If this is not done, then as in figure C, the user will see the direction where the robot is headed right away. So obviously this needs that the user then must have a means to physically rotate themselves, such as swivel chair. So we pre-registered 4 hypotheses of what would happen if for a robot, the telepresence robot moving autonomously and the person aboard through an HMD. So what would happen if the rotations are unwound? So those hypotheses were that the users would get less sick, they would prefer the unwinding and they would find it more comfortable. And finally, they would retain their sense of orientation such that the error in path integration is not increased. We worried this might happen if people do not rotate themselves to face the robot's direction of motion. Then it might be that they lose their sense of orientation, which is something we don't want to cause for telepresent people. So to test our hypothesis, we designed a virtual environment in Blender and Unity. We had 34 participants who saw 2 conditions of the same video, either unwound rotations or coupled rotations, which is what we call when the user's viewpoint rotates along with the robot. We also collected head motion data during the experiment, asked participants questionnaires, and at the end asked them to point towards the origin. And we had also some simulated humans there, as you see on the figure on the bottom left. And then I can happily say that all our hypotheses were confirmed. To measure VR sickness, we used the simulator sickness questionnaire, the SSQ, a very standard method for measuring VR sickness. There was a significant difference. Then for preference and comfort, we used forced choice questions after the participants had seen both videos. And there was also a significant difference. We also asked about intuitiveness. We didn't pre-register that, but users found it intuitive also to rotate themselves. And there was no significant difference in the path integration error. Other results. So we actually, through the head tracking data, we found out that the participants did rotate themselves to face forward as in the robot's direction of motion. Even though we never told them they have to do it, they still instinctively did it. And as you can see from the figure, people had also a different amount of rotations. So the two figures above are from the same participant, the two below are from another participant. So some looked around less, but it made no difference whether there was unwinding or not. And also the speed of 1 meter per second was considered adequate. Distance to walls was okay. However, 1 meter distance to people from the camera viewpoint was considered a bit too close. So, to conclude, that for autonomous motions of a telepresence robot, it's beneficial to unwind the rotations rather than make the user's viewpoint rotate with the robot. There's a bunch of interesting follow-up questions, such as now we assume that the user can, for example, use a minimap to choose the destination. However, if somebody wants to use a joystick, is it still okay to unwind the rotations, or does that make it too confusing for users? Does unwinding increase the feeling of presence even? We had some of the qualitative data pointing that way. We might want to study that, check that in the future. And then, of course, further research in two-way communication through HMD and the 360 camera, because now we only consider the remote user watching things. And then we also presented a future work of showing this with a real robot. So we are happy to say that we are currently have run the experiments and we are now analyzing the data. And hopefully by the time the conference happens, I can give you an archive link to a submitted paper showing what happens when all this is done instead of simulation. It's done on a real robot. That's it. Thanks a lot. Please don't hesitate to send me a mail if you have any further questions. I will be happy to talk to you about this, and thanks for listening.